This is a video from section 5.5 found in a Calculus 1 class. The problems will be taken out of the Stewart Calculus textbook, 9th edition. And we're going to start off with problem number 43. Suppose we're given the integral of hyperbolic sine squared x times hyperbolic cosine x dx. Now, this problem can be done by u substitution. And so what I'm going to do is I'm going to let u equal hyperbolic sine of x du. So the derivative of hyperbolic sine of x is hyperbolic cosine x. So we write hyperbolic cosine x dx. And so this is the integral of u squared. And then hyperbolic cosine x dx becomes du. And so this is equal to 1/3 u cubed plus c. But remember that u is hyperbolic sine of x. And so this is equal to 1/3 hyperbolic sine cubed x plus c. And that's how we do problem number 43. Let's take a look at problem number 45. Suppose I'm given the integral of sine 2x divided by 1 plus cosine squared x dx. Now, one thing I would like you to recall, there's a couple of things. Now, sine 2x is equal to 2 sine x cosine x. This is the double angle identity for sine. And then also that the derivative of cosine squared x is equal to 2 cosine x times negative sine x. And I go, that looks like negative 2 sine x cosine x. And that gives us a very good candidate for what we should choose for u. So what I'm going to do is I'm going to let u equal 1 plus cosine squared x. Du is 2 cosine x times negative sine x dx. But what that tells me is du is negative sine 2x dx. So if I take sine 2x dx, this is equal to negative du. And that allows me to plug stuff in. So this is equal to negative the integral of 1 over u du. But this is negative the natural log of the absolute value of u plus c. But remember that u is 1 plus cosine squared x, which is greater than 0, by the way. So please make note of that, because when I write my final answer, I don't need to put absolute value bars around what u is, because 1 plus cosine squared x will never be negative, no matter what you input for x. So the answer is negative natural log of 1 plus cosine squared x plus c. And that's how we do 45. Let's take a look at problem number 49. suppose we have the integral of 1 over the square root of 1 minus x squared times the inverse sine of x dx. Now, it just so happens that if I take the derivative of arc sine x, I get 1 over the square root of 1 minus x squared. So that gives me a pretty good candidate for u. And so I'm going to let u equal the inverse sine of x. Remember, your goal is you're trying to get rid of anything that involves an x, essentially. So du is 1 over the square root of 1 minus x squared dx. And so this is a game, again, of substitution. And so we're going to plug stuff in now. So this is the integral of 1 over u, and then the 1 over the square root of 1 minus x squared combined with dx will become my du. So I get the integral of 1 over u du, which is natural log of the absolute value of u plus c. Remember, we're trying to transform it into an integral that's more manageable, basically. Okay? Now, note that u is arc sine x. And so I'm going to stuff that back in. I get natural log of the absolute value of arc sine x plus c. That is problem number 49. I want to take a look at 51. Suppose I had the integral of 1 plus x divided by 1 plus x squared dx. This is a fantastic question, by the way, because the way you're going to have to do this problem is as follows. We have to split this up. So we're going to write this as 1 over 1 plus x squared, the integral, plus x over 1 plus x squared dx. But that's the integral of 1 over 1 plus x squared dx plus the integral of x over 1 plus x squared dx. Just like this. Now, what we're going to do is we're going to we'll call it L equal the integral of 1 over 1 plus x squared dx. Okay? In fact, let's do one better. We'll call it L1. And so L1 is equal to inverse tangent of x plus, we'll say, C1. And I'm going to let L2 equal the integral of x over 1 plus x squared dx. Now, to do this integral, we need a u substitution. And so I'm going to let u equal 1 plus x squared. I just happen to know that if you take the derivative of the denominator, you almost get the numerator. It's off by a constant, which is okay, because we can always adjust for that. Now, du is 2x dx. But if I solve for x dx, I get 1/2 du. And so L2 is 1/2 the integral of 1 over u du, which is 1/2 natural log of the absolute value of u plus, and again, we're going to call it C2. But u is 1 plus x squared, which is always positive no matter what you input for x. And so therefore, L2 is, well, it's going to be 1/2 natural log of 1 plus x squared plus C2. And so, therefore, the integral of 1 plus x over 1 plus x squared dx is L1 plus L2. And this is arctan x plus 1/2 natural log of 1 plus x squared plus some constant c. And you could say where c is C1 plus C2. And that's a pretty good stopping point. That'll conclude this video for section 5.5. We worked on problems 43, 45, 49, and 51. Thank you.